1, 2, 3. Greeting, folks. This is Prof. KW. Today I want us to look at what we call functions for grade 10. And we know that functions that are divided into 4. The first one that I want to focus on is what we call linear function. Linear basically is just a straight line, right? Okay, so it's in a form of, there is a one in a form of x equal to c. Example of this one, that is when maybe you have x equal to 2. So graphically this will be, this is your y-axis, this is your x-axis. So this will be something like this. Here your axis is 2. And the other one is in a form of y equal to c. If one can say the y equal to positive 2. Obviously, graphically, this would be something like this. We said this is our y-axis, this is our x-axis. So it will be a line like this one, whereby we say y here is equal to 2. Okay, which means here we have 2. And the other one is this one, which is y equal to mx. The example of this one obviously would be y equal to x. If we are required to sketch this one, here you have 1, which means the coefficient of x is positive 1. If you put 2 here, which means where there is x you put 2, obviously your y will also be 2. So you have a point like this one. And if you put 0 here, which means your y would be also be 0, then it would be something like this. So we say this function is y equal to x. Then the one that I want us to focus more on is this one, which is y equal to mx plus c. Let me start with this one. This is what we call Y-intercept, which means that is where the graph would cut along the y-axis. For the y-intercept, you will always make x be 0. That is what is important. Or this one, it's what we call a gradient, and this is also very important. Then here we say, if your gradient is greater than 0, meaning it's positive, so your graph will be something like this. You use your right hand rule, so it will be something like this. But if your gradient is less than 0, which means your gradient is negative, this means you would use your left hand rule, this one, which means your graph would be something like this. Don't forget, this is our y-axis, this is our x-axis. But what is important with these two is that for this one, this is what we call a decreasing function. Why this one is a decreasing function? It's a decreasing because if you look at x, as x is increasing here, but your y is decreasing. So that's why we say this one is a decreasing function. This obviously is an increasing function. And we say, why we say this one is an increasing function is because as x increases, you can see the y is also increases. So that's why we say this one is an increasing function. Let's look at an example now of the linear function in a form of y equal to mx plus c. Then what we will do, this is our linear. Let's give an example of this one. Let's say you are given 2x plus, you'll see here, let's say this is minus 4. So the first thing that you will do, you look for what we call x-intercept. X-intercept, what you will do, you would let your y be 0, which means where there is y, you put what? 0. So this now will be 2x minus 4 equal to 0. obviously you have to make x be the subject of the formula. You transpose 4. Your 4, you can see it's negative, but then after transposing, obviously, now it's positive. Then you divide by 2. So these 2 cancel each other out. Then you say 4 divided by 2, this will give you 2. So in a coordinate form, we know that the coordinate is something like this, is x and y. So what is our x here is 2. Obviously our y there is 0. That's the first thing. The second thing is what we call Y-intercept. For the Y-intercept, what you do, you let x be 0, which means where there is x from here, you would put what? 0 minus 4. Obviously our answer here is minus 4, because if you say 2 times 0, that will give you 0. But in a coordinate form, this would be 2 and not 2. Our x here is what? It's 0 and negative 4. Then now let's say the question says sketch this graph. Okay, we know this is our y-axis, this is our x-axis. You get the scale here. Here you have 2, but here you have 4. So you can use 2 and 4 this side. Obviously negative 2 and negative 4. This can be 2, this one can be 4. Negative 2, obviously this is negative 4. Now our first coordinate is 2 and 0. This is 2 and 0. And we also have 0 and negative 4. This is x is 0, but our y is negative 4. Then this is your graph. Then you join these 2 points. So this is obviously a straight line. So this function is y equal to 2x minus 4. And what you have to take note here is that your gradient, let me indicate it here, your gradient here is equal to 2. So which means our gradient is positive. So if our gradient is positive, this would say this should be an increasing function. How then one can see whether the function is increasing or not? If the function is increasing, the graph must indicate that both x and what and y increasing. Let's check that one. If going this side, okay, let me go after 2. This one, this is 3, but look at the y. Your y is increasing. If your x is 4, and you can see also the y is also increasing, so which indicate that this is an increasing function. So it's very important to take note of the gradient there. Okay, let me give you the last example, obviously with a negative gradient now. Okay, with a negative gradient, this will be, let me say now this is g of x is one of the notation, minus 2x plus 4. Now you can see our gradient is negative. But then what is important is that the first thing that we have to work it out is your x-intercept. For the x-intercept, you obviously let your y be 0. So your y is your g, which means you put 0 here, negative 2x plus 4. Then how can you solve for x? You transpose this one. This will be positive 2x equal to 4. Then you divide everything by 2. Obviously this would be x equal to, you say 4 divided by 2, this will give you 2. In a coordinate form, this would be 2 and 0. Then for the y-intercept, what you would do, you would let x be 0. So which means where there is x, here is your x, you put what? 0 plus 4. So your final answer here will be positive 4, because when you say negative 2 times 0, that will give you 0 plus 4, that will give you positive 4. In a coordinate form, you start with your x, which is 0, and your y is positive 4. Now, our sketch will be something, this is just a rough sketch. This is our y-axis, obviously this is our x-axis. Then we have 2 and 0, okay, this is 2, obviously is 4, negative 2, and this one is negative 4. And here we have 2 and here we have 4, obviously below the horizontal your y is negative. Now our first coordinate here is 2 and 0, there we go. And our y is 0, our y-intercept is 0 and 4, here is 0, here is 4. Obviously you join these two. Wow, this is our function, which is g. Wow, but if you can look at this one, your gradient is less than 0 as the gradient is equal to negative. So this one obviously should be a decreasing function. So let's check whether this graph is decreasing or not. How can you see that? Is that if the graph is decreasing, we have to firstly look at x. As x increases, what we have to check is our y, because our y should decrease. So that is what is important. So if you look at this one, this is 0, but going this side, our x here is 1, but our y is 4. When the x is 1, you can see that as x is 1, your y is decreasing. And when your x is 2, your y is 0. Or obviously this one is a decreasing function, which means we are 100% correct. So that is all about what we call linear graph, I think.